Chapter 7, Correlation and Regression. In this lecture, we will learn how to draw a scatter plot for a set of border pairs and compute the correlation coefficient and write the equation of the regression line. Start with the scatter plot. Now, a scatter plot is a graph of order pairs x and y of numbers consisting the independent variable x and the dependent variable y. So let me remind you, independent here x affects y, affects y. So the one affecting the other one is the independent, and the one getting affected is the dependent. Now it is used to reveal graphically any relation between two variables. So by the scatter plots, we are able to tell if there's a relation between x and y. Now in this example, we'll construct a scatter plot for the student score in the exam and the number of hours that students study per day for exam, and the data is shown below in the table. Now here the x values are the number of hours of study and the y values are the scores, and here x is the independent variable for sure. We believe and we deduced that the number of hours are affecting the score of the student. So this is independent here. This is the dependent variable. This is how it goes. And we want to do a scatter plot for this. So in order to do it, okay, you have to see them as ordered pairs and then put these ordered pairs in the Cartesian coordinate system, and you will have these points here. Okay, we will see them in the next slide. Now, first, we'll look at the table here, the data, and we have x, and we have the independent variable x, and we have the variable, the dependent variable y. So first we draw, okay, we draw the x and the y-axis. Okay, this is the x-axis, this is y-axis, and always, I mean, generally, and most of the time, we put the independent here as x, and y, the dependent variable here on the y-axis, and we plot the points here: 686. Okay, 686 is here, and 261 is here, and 152 it's here, and then 789 it's okay. It should be this one. Okay, and 365 is this one here. If you see here 365, so it's corresponding to 65 here, and these are like plotting the points in usual mathematically. This is how we plot the points. 470 will correspond to that one here, 4, and here 70, so it will correspond to that point. So these are so this makes a scatter plot for the number of study and the grade. So the x is the number of hours of study, and the grades are y. So this is the scatter plot for x and y. Now we have the graph x versus y. So we have the scatter plot for the number of hours of study. So this is the number of hours of study and this is the grades here. These are the grades. Now we have the scatter plot. Now the question is there a correlation between the hours of study and the grades? Here the correlation means the relationship between two variables. In statistics, correlation means the relationship between two variables. So is there any relationship between x and y? And if there is, what type of relationship it is? Now, when you look at these points here, it's for sure this is x, as x increasing, y is increasing. And when you look at these points, they roughly look like lined up on a line, something like this. So this type of relation, we can say like it looks like the relationship is like the relationship is linear, looks linear. So linear means like a line here. Now, and as x increases, y increases. So we say, so it has a positive relationship because as x goes bigger, y is going bigger. So the direction is going up. So we say this is a positive, and the relationship, it looks like linear and positive relationship between x and y. So we will look at the other types of relationships from on the scatter plots. Now let's look at these examples. Now, for example, here the data. Okay, look at the data here. The data is going down as x goes down, y is going down. I mean, as x goes up, y is going down. So this is um, y is increasing. So sorry, y is decreasing. As x increases, y tends to decrease. So we say this is a negative relationship, negative correlation. And does it look like linear? Okay, linear, I will say linear to some extent. Not really linear, but to some extent, yeah, it looks like linear. So we say roughly it's a negative linear correlation. Now, let's look at another one. Now, when you look at this one here, um, as x increases, y is also increasing. So, it's going this way. So this is a positive direction. We say there's an increasing graph here, roughly. And then look at the point here. The points, okay, they behave a little, okay, not very linear, but when you look at the direction, it's kind of linear, okay? Not really linear, but we can say this one weak linear. This is weak linear. Now, we will learn how to classify them by looking at the pictures and by calculating some values. But for now, uh, you have to learn what is positive behavior, what is negative correlation, and the linearity. So let's look at this example. Look at here. Any direction going up or going down, no direction. And is there any line behavior here? No. So for this reason, we say there's no correlation. We cannot say it's negative, positive, or we cannot say it's linear. Now let's look at here in this one. Uh, this behavior is like going up, then down. So it's not a linear relationship. I mean, if it is linear, it has to go this way or it has to go this way, but there's no general tendency here. So for this reason, this is not linear. And if you look at is it positive or negative? Now it's not clear because this part looks positive, but this part looks negative. So we don't say anything. But we can say it's nonlinear correlation, okay? Because the relation doesn't look like a line, okay? So nonlinear, so it's not linear. It doesn't look like a line. Now let's look at some scatter plot examples and let's try to figure out the correlation here. So now let's look at the first one. As you see the x values and y values here, I mean, when you look at the graph here, it's definitely, it's almost like a perfect line. It makes a perfect line. So we say, and the direction here, so the direction is going up. So we say it's a positive, perfect linear relationship, correlation. Now, when we look at this part here, it's still positive because it's going up as x goes up, y goes up. It's a positive. About the linearity, so the linearity is kind of Okay, we'll not say perfect, but it's obviously a strong one. It's strong or moderate, uh, strong or moderate, a linear relation. And when you look at here, look at this data. This is it's spread too much, so it doesn't look like a line, but still it has a general tendency toward up. I mean, uh, so it's an upward direction. So I will say this is positive, and we can say it's a weak linear relation because it doesn't look like a line. It has some, some direction, but it's a very weak linear correlation. Now, when you look at this part here, we don't see any direction. Is it like and the spread? It doesn't look like a line, so we say no correlation at all. And when you look at this part here, so as you see, it's going down now. So we say negative. And when you look at this, the thickness of the data here or the spread, so we say it doesn't look like a line, but we can say in this case it's a very weak linear correlation. Now, when you look at this one, it looks like a little thick line, and it's going down, so it's negative, strong maybe, or moderate, strong or moderate. We will give you some criteria to tell them. Linear correlation. Now, when it comes to this one, this is negative for sure, it's going down. And here, all the points are lined up on a straight line, so we say it's a perfect linear correlation. So on the graphs, you have to check two things. Correlation, we check two things. Direction, positive or negative. And the other thing is thickness of data or spread of the data. So it means you can say the thickness. So spread of data is you say it's very weak linear, so you can say weak linear up to perfect linear. There's a strong, strong, and a moderate here. So in the correlation, you have to tell positive, negative, weak, or strong or perfect linear. You have to tell this. Now, how can we measure correlation? So assume you don't have graph. Okay, I mean you can check. You can make a graph. You have x and y's here. These are given to us. You can make a graph and see the relation. But we have a measure of correlation, and this measure of correlation is called coefficient correlation. Coefficient of correlation, and it's found by this formula. This is called correlation coefficient, and it's given by R, and it's a measure used to determine the strength of the linear relationship between two variables x and y. And if this formula is used for the sample, so this is sample data here, then we say it's R. But if it is the population data here, this is population data, we use raw. Okay, these are the symbols for it using different statistics like sample or population. Now, what we do here is how to find it. These values x and y's, they're given here, so we have to find this x times y and the other stuff, and we will find the values and it will put them here and it will give you a number. And always this R, you will get something between 1 and -1. If you get a number with this formula, if you get a number outside these interval, I mean this interval, it means you're doing something wrong. Now we will see in an example how to apply this formula. Now again, let's get back to our first example. We have the hours of study for the students and the exam scores, their exam scores, and we want to see their relation. I mean, from the scatter plot, we remember it was kind of linear, and let's see the correlation coefficient. Now, here we have to calculate x times y. So this is how we do it, like 6 times 86 is equal to 516. And this x squared is like 6 squared. Okay, 6 squared. And let's write this one here. This is how we do it. The 6 times 68, which is 516. And then y squared. This is 86 squared. Now we will find each of them. Okay, you will find them by calculator, and then you will look at the totals. You know that you add them here, you get this one. You add them here, you get this one. You add them, you get this one. You add them here, you get this one, and you add them, you get this one. These numbers we will need them in the formula. So here we need the sum of the products, sum of the x's, sum of the y's, and here there's a square root, a huge square root. And under this one, there are two terms, one term and the other term. And in these terms, be careful, this is the sum of the x squares, and this is the square of the sum of x. And we have the same thing for y. Now we will put them from the formula, from the table. We got these values in the previous slide, and then we'll put the numbers here. We'll get 0.99. So we get 0.99. What does this mean? So this means, okay, R is always between 1 and -1. The sign of R says the direction, positive or negative. Now, when you look at here, the sign here is positive. So you say it's a positive relationship. And one other thing is, if it is close to 1 or -1, if R is close to 1, okay, if R is very close to 1, or R is equal to -1, it means it's almost like perfect linear relationship. So here we have very close to 1, so we have a perfect linear correlation, but its sign is positive, so it will be positive. Now, if you have a problem in finding, I mean, it's easy to calculate the coefficient of correlation, but if you have some, if you want to see clearly which R corresponds to what, I can tell you, okay, if R is close to 1, therefore it's a positive, so it's positive here, this is positive, and close to 1, so it means strong linear relationship between X and Y. Now here is some properties of the correlation coefficient of R. So we know it's between -1 and 1 all the time. And if R is very close to 1, it means it's a strong positive linear relationship. If it is close to -1, it's a strong negative relationship. So being close to 1 or -1 means strong, okay? And getting away from them, so it means like getting to 0, it's a weak linear relationship between the variables. And R is equal to 0 means no linear relationship at all. And a strong correlation means there's a strong linear relationship exists between two variables, but it doesn't necessarily mean X causes Y to change. This we can say X affects somehow to Y, but we cannot say X causes Y to change. So here is a good classification of R values and their interpretation. So if you get r equal to -1, you say the relation is perfect negative linear relationship. If r is between -0.07 and 0.99, you have strong negative linear relationship. And if you have between -5, -0.5, -0.69, you have moderate negative relation. So as you see, since it's negative all the time, it's all negative here. So you have to check just, it's for sure it's negative. You have to check, is it perfect, strong, moderate, or weak? If you have these numbers, a number between them, it's weak. And if you get 0, so it means no linear relationship. And in the same way, we have the positive. It's all positive here. These are all positive. And your R values, if it is 1, perfect positive. If R is between 0.7 and 0.99, it's strong positive. If it is between 0.50 and 0.69, it's moderate positive. And if it is between 0.01 and 0.49, it's weak positive. And if you get R equal to 0, it's no linear relationship. So you can use this table to describe the relationship between X and Y, by looking at their coefficient of correlation. Now, okay, forget about this part. Just let's look at here and let's try to guess the correlation values here. This is positive and perfect linear, so it will be +1. And here it's negative for sure. It's perfect linear. It's -1. It's correlation coefficient. Now here we have some strong linear, but up it's positive. So we expect it to be around 0.8. It might be also 0.9 or 0.825, but these values are approximate values. Okay, these values are approximate values. These, since they are perfect, they're okay. Now here it's weak, 0.3, and here you expect it to be also weak, negative. It's negative 0.3, and this is a kind of strong and negative also, so you expect it to be negative 0.8 or 9. So what we want from you is you should be able to guess the correlation coefficient from the picture, and when we give you R values, you should be able to tell us, is it positive, strong, or weak, or moderate. You should be able to tell. Now let's do this activity, and we have 4 plots and 4 correlation coefficients. So we will match each plot with its correlation. Now look at these pictures, and let's look at plot 1. We have a positive tendency, but when we look at here, it's spread. It's too much spread. So it will be positive for sure, but linearity, very weak. Very weak. So it should be a positive value, not this one, not this one, and not a strong one. So it has to be weak. So we can say it's plot 1. This is plot 1. Now let's look at the second one here. We have a plot and the points are like going down. It's for sure R is negative, and linearity is again weak. So we expect something like negative number. So let's look at here. We have 2 negative numbers here, but it cannot be close to 1 because it's not perfect linear. So it has to be only this option here, B, plot 2 is here. Now when you look at this part here, it's going up and kind of more concentrated around the line. So it's like spread is a little. So this will be, it's a positive one, and it will be kind of close to 1. Okay, not perfect, but close. So the only option is C here. Now the rest is, of course, this will be plot 4 because this is almost like linear, very close to 1. but it's going down, so it's negative. So you expect R to be a very negative number, very close to 1. Now we will talk about the regression line. So assume we checked if there's a correlation between two variables and assume we got a linear relationship. We say it's moderate or strong. So in this case, we will try to get a line to estimate the behavior between X and Y. And this line we will use is the regression line, and which is the data's line of the best fit. So, okay, now best fit means this. So we want to make a trend line here. So we can say, okay, their relation looks like this line. And this is one line we can draw. And some other guy, he can say, hey, this is the best one, it looks. And some other guy can say, hey, this is the best one here. So here are the options for the lines. So one of them is the best one. So one of the lines here is the best one, the best fit. We call it best fit line. Okay. Now the best one has this property. So the best line, which one is the best one? So the line with the minimum error is the best one. Now what we mean is this. So when you draw a line, of course you will expect these errors here, these distances. Look at these distances here. We want these, the sum of these errors here, sum of the squares of the vertical errors here, the distances here, this is the distance. So sum of the distance squares should be minimum here. So if you make a line like this, so look at the distances here from the points to this line here. The distance squares are too much, right? So for this reason, this cannot be a fit line because the distances are not minimum here. But if you draw the line, this way, now it looks, this one, it looks kind of, um, the errors, the distances are very small here. So this type of, line, we call it the best line, the best fit line. So the question for this line is this: what is the equation of this line? Okay, the best fit line is also called regression line. Regression line. So it means best fit line. So regression line, the best fit line. So our question is this now: what is the equation of this line? How can we find it? So for this, the mathematicians or statisticians already calculated the formulas for them. Formulas for the regression line, like the equation of the regression line. It's a line on the x and y axis, so it has to be some equation like ax plus b. But be careful, in mathematics we use ax plus b, but in statistics we use a plus bx. Okay, be careful here, b becomes the slope here, slope, and this is y, so a is the y-intercept. It is just the opposite of what we did in mathematics. Now we can find this a and b by using the data value. So here, how do you use, where are these x and y's? So because we give you x and y's on a table here, right? So we said this one is 52 and 2 is like 60, 65. We gave them. So by using them, we'll get like x squares and y squares and the x y's and their sums, sum of x y, and we will put them in here, and this will give you the slope of this regression line. The slope of the regression line is b. And how can you find a then? So once you find b, then you will find a by doing this: y hat minus b times, y over line y minus b x over line. So these mean the mean of y. How do you get the average of y? So you add all y's, divide by n. What is n here? N is the number of data here, so the number of data. So then x bar is also the mean of x, which is the number of x, so x divided by the number of data values. So by using these two formulas, we'll be able to calculate a and b. And one thing here is this. If you have, okay, assume you have a data and, okay, let's do some observation here. You have some points here, and then you make the line. And as you see, this is the coefficient of correlation. Since it's positive, it has to be positive, right? Now, because the data is going up. Now, but when you use this regression line, its slope is also positive. So because the line is going up. So in this case, the sign of correlation coefficient and the slope of the regression line have the same sign. B and the coefficient of correlation R have the same sign. And the other property is the regression line can be used to predict a value for the dependent y for a given value of x. So we will see this in an example. It is very easy. Now, let's look at this question. Let's do this example. Refer to the data of students of scores, students studying time in hours. So it's given in the previous example. Find the estimated simple linear regression line that best fit the data. And the second question is find the predicted value of y at when x is 10 using the data in example 1. Now, okay, if you remember, we have this x and y. Just it was the first example we gave, and then we also we did the scatter plot of the points and see the relation. It was like kind of linear and strong. Anyway, now we will try to find the simple linear regression line by using these information here. So we find them by using a calculator. We find all these values and then put them in the formula. So in the formula of what? In the formula of the slope. This, the line we're looking for is this y is equal to a plus bx. Now, how can we find b? So by using this formula. And by the way, these formulas will be given to you. These formulas will be given in the exam, so you don't have to memorize, but I want you to do exercise. Okay, so don't come like without doing anything. Just so you have the formulas does not mean that you will do good in the exam. So please do some practice with the calculator and do these questions. Now we will put these values in the previous slide. We got these values as totals, and then n is the number of points or the number of the x values and the number of the data. If we put them here, we have 6 values, and we got these sums, and we will put them here, and we will get 6.2. And then after we get the slope b, we will find a. So how can we find a? By using this formula here, y, the mean of y, the average of y, minus b times the average of x. Now, how can you find y, the average of y? This is the sum of y's divided by n. This is the sum of the x's divided by n. So this becomes the average of y, this becomes the average of x, and we put them here, and we know 6.2 is b, and we calculate, and we get a is equal to 46.3, I mean 46.7, and then we can write the equation now. The equation will be 46.7a plus bx, so b is 6.2 and x. So this is the equation, will have some y and x in it. So this is the regression, the equation of the regression line. Let's come to the predicted value for y when x is equal to 10. So this is very easy. Just you put here x equal to 10 here, for you substitute 10 for x in the equation, and the corresponding y value is your predicted value. Now the predicted value is this. You have these points and you have a regression line, let's say. This is your regression line, let's say, and then the if x is 10 here, let's say, this point on the line, the y value on the line, is your predicted value for x equal to 10. So here you got 108.7. So these points on the line are the predicted values for any x value. And even it can be same here, like the real data here 152, but you can put here x equal to 1 and you can get its expected value from, its predicted value from the line also. Anyway, the bottom line, when you have x here, you will put it in the equation and you will get the predicted value of y. That's it. And now we will solve the worksheet problems. Question 1. If the relationship between y and x is given by the equation y equal to 1.57 plus 0.0407x, which of the following is true? So in A it says for every unit increase in x, y increases by 1.57. So here what this means is this, like if x is 0, y has some value, let's say what happens when you put here 0.57 plus 0.407 times 0. You put the x value and you got y equal to 1.57. Now if you increase x to 1 unit, so it means you increase 1 unit, what will happen to y? So you can check by calculating y value. This is 1.57 plus 0.407 times 1. So it seems we will get a y value which is 0.407 more. So you see here, you look at this one, y changes, y increases by 0.407, 0.0400 anyway. So in this case, when x is for every unit increase in x, there will be increase 0.0407 in y. So this is not true, but this is true. For every unit increase in x, y increases by 0.0407. And you can see it from here because the coefficient of x is 0.0407. So any increase in x will be multiplied with 0.0407. So this will cause y to increase by this value. Now let's look at the others. So all of them are not true because A is not true. The correlation coefficient has a negative sign. So we know that the correlation coefficient and the slope of the line, slope of the regression line has the same sign. So the slope here is what? The slope is 0.0400. Slope is positive. So a correlation coefficient cannot be negative because it has to be positive. So this is also wrong. So the only answer is C. The correlation coefficient and the slope of regression line will always have the same sign. Let me give you the explanation. Assume the data has a positive correlation coefficient. This data here in the scatter plot, you have this one. Now when you look at its direction is positive, so it's going up. So the correlation coefficient will be positive here, so because it's going up. And if you make the line here the regression line, okay, the regression line will be something like this maybe. And when you look at the slope here, the slope of this line, it will be also plus because it's going up. So always the correlation coefficient and the slope of the regression line have the same slope. So, and I mean, have the same sign. So this is always true. What is the chart called when the paired data, the dependent and the independent variables are plotted? So we are talking about uh, a scatter plot. So a graph, there's a paired data, so it's x and y pairs, and let's say x1, y1, x2, y2, and these are put here, these are plotted as points here, the order pairs, and you can have more here, so you will put them here. Now this type of plot is called scatter plot. And the others, the histogram and or give graph, they are about the frequencies, not two variables, but just one variable with frequency. Time series is just time versus the variable. Simple linear regression equation, the symbol x represents what? Okay, in a simple linear regression equation, it means a plus bx. X is always independent variable, and y is called the dependent variable. So I can give you an example of this h and let's say height. So which one affects this one? Which one? So definitely we believe that, and we know that the age affects the height. You know, by looking someone's height, you cannot say his age, but indirectly. But if we say the age of a person, then we can guess his height. Okay, so for this reason, age affects the height. We say so. If this affects age affects the height, so we say this is independent. This is dependent. So because height is depending on the age, let's say in general. Now here x is representing the independent variable. It has to be independent variable, and there's nothing here as independent variable, but also we have to remember this. Another name for independent variable is the explanatory variable. This is explanatory variable, and the dependent variable is the outcome variable, as far as I remember. It's outcome variable or resulting variable. Okay, the outcome variable, I guess. So the explanatory variable is another name for independent, so it will be just B then. So the range of Pearson correlation coefficient value R is, okay, the range means the set of the values it takes. So it's an interval generally. So we know that the R, the correlation coefficient, is always between, takes a value between -1 and 1. So it will be just B. When all points fall on the regression line, what is the value of the correlation coefficient? Okay, I will correct this one. I mean, I will make it clear. When all the points on in a scatter plot, okay, on a scatter plot, I will say scatter plot fall on the regression line, what is the value of the correlation coefficient? So we will have, okay, assume we have some data, and we have all the points are falling on a line, and this line is regression line. So in this case, what do you say about R? So it's perfect linear. Okay, it might be positive or negative, because if this is the case, it might be, the same thing might happen here. Again, it's R is here, it's perfect linear, but it might be -1. We know it might be +1. So in the perfect linear case, this is where the points fall on the line, regression line, perfectly. Then we have R equal to -1 or 1. If the correlation coefficient R is equal to -97, when there is, then there is what? Okay, now R, if you remember the R schedule, R scale. So R, if it is 0, no linear, no correlation. If it goes to 1, it's perfect, positive, linear, positive, perfect linear correlation. They have, and here it is -1, and this will be just perfect, positive, negative, positive, sorry, negative, perfect linear correlation. But if it is close to -1, let's say -0.9 or around here, so we just say it's very strong, not perfect, but strong linear, and which is, since it's negative here, so it will be negative strong linear correlation. Correlation means relationship. So according to here, it has to have negative relation between, okay, no relation, not. It will be a strong and negative. So strong and negative relation between two variables. It's B. Now let's look at this question. Suppose 5 individuals with the same initial systolic blood pressure are given a blood pressure medication, each with a different dosage. After a period of time on the medication, a random sample of 5 individuals have their systolic blood pressure measured. Results are summarized below. Now here, the table is not given to us, but the values from the table is given to us here. Obviously, Y is the blood pressure, and X is the dosage of the medication. And because the medication affects the blood pressure, so X is dependent here, and X is independent, and Y is dependent. Anyway, so we want to see the correlation here, the correlation coefficient, and there's a formula for it. And this formula is indeed, it's equal to n times the sum of the xy products and minus the sum of x times the sum of y values, divided by the square root of n times the sum of x squares minus the square of the sum of x, and then the square root of n times sum of y squares minus the sum of y squared. Now we can put them in here. We can substitute them in the formula. It will be 5 times x times y, this is 20,350, minus the sum of x, this is 150, times sum of y, this is 695, and minus divided by square root 5 times 5,500, minus sum of x squared is 150 squared, times square root n is 5, then times y squared, sum of y squared is 96, 5,925 minus sum of y squared is 695 squared. Okay, if we substitute correctly, then okay, we can check again. This y is 695. This one is y squared, and yeah, it's always better to check your numbers again in case you do a mistake. Okay, and this is okay. Anyway, so by okay, with the help of a calculator, you can find this is equal to negative 0.883. Yeah, so this is the correlation coefficient. So what can you say about the linear relationship between x and y? So this is here minus, so you say the the relationship is negative because it's negative, and this value is close to 1, so I would say negative strong uh, linear relationship, relation or correlation. Now we will find the y-intercept and the slope for the regression line, and for them we have some formulas, and we will use the formulas here. For the b, which is the slope here, okay, for b we have this formula here. You know it's b is equal to n times the sum of xy products minus the sum of x times the sum of y divided by the square root of, so no square root, sorry, this is slope. This is sum of x squared minus the sum of x squared. So then if you put all these values here, 5 times 20,350 minus 150 times 695 divided by 5 times 5,000, I mean 505,000 minus 150 squared. So this will be equal to, okay, when you use a calculator, you will be able to get it's negative 102. So it's negative 102 or negative 0.5. Now, okay, we got that one. So I will say this is negative 0.5. Maybe is negative 0.5 then. Okay, how can I get A, the y-intercept here? This is the formula for this one is like A is equal to y hat, I mean y, the mean of y, the average of y times minus b times the average of x bar. So this means that y bar can be calculated by the sum divided by n, sum of y divided by n minus b times the sum of x divided by n. So the sum of y is 695 divided by 5 and minus the sum of b. What is b? b is negative 0.5, so be careful about the minuses here. So this is sum of x 150 divided by 5. So when you use a calculator, you will end up with 154 here. So then we will have a as 154. So I will write it as a is equal to 154. Now, what can you say about the equation, right? The equation of the regression line. We already have the slope and the y-intercept of the line equation. So it has to be y equal to 154 minus 0.5 x. So this is negative, as you see here. Okay, and we generally put in statistics, we put a hat here. In mathematics, we don't put it. But anyway, we can put or not put, but in statistics, it's a, I think it's used this way. To predict the systolic blood pressure for an individual dosage, x equals to 64. So it means it's asking predict y when x is equal to 64. Basically, it says this. So what you have to do is you have to substitute 64 in here. Then you will get the predicted y value as 122. Okay, I think that's it. Thanks for watching.